Okay, 5.3 is the end of the things that you need to know for your trig values assessment coming up. So in this section, we are going to be going over the remaining 4 trig functions: secant, cosecant, tangent, and cotangent. And we're going to do those for our special angles. 30 degrees, it's pi over 6. 45 degrees, pi over 4. And 60 degrees, pi over 3. We're going to use reference angles to evaluate all trig functions. Use properties of even and odd trig functions. Recognize and use fundamental identities. And then evaluate trig functions on a calculator. All right. We spent 5.2 talking about sine and cosine, where we use the coordinates x and y to evaluate trig functions. If our angle is t, then we know that x is cosine t and y is sine t, with radius, hypotenuse being 1. All right, so we know that cosine is x over radius. On a unit circle, the radius would be 1. Sine would be y over radius. The remaining trig functions come from those x's and those y's and the radius. Tangent. Okay, tangent is y over x. Remember tangent? Opposite over adjacent. Okay, opposite of angle t was y. Adjacent to angle t is x. So tangent, y over x. Secant, this is the reciprocal of cosine. All right, so if cosine is x, then secant must be 1 over x. Cosecant is the reciprocal of sine. So if sine is y, then cosecant is 1 over y. And cotangent is the reciprocal of tangent. Well, tangent is y over x, then cotangent must be x over y. All right, so I've got an ordered pair, negative root 3 over 2 and 1/2 on the unit circle. So first thing I'm actually going to have you do is figure out what that reference angle is. This is a unit circle value. Okay, so if I look back on my unit circle, find my x, negative root 3 over 2, positive 1/2. My reference angle, my angle there is 5 pi over 6. Okay, so that makes my reference angle pi over 6. Okay. All right, so sine is the y-coordinate, 1/2, which means we know cosecant, because that's the reciprocal. Reciprocal of 1/2 is 2. Cosecant is negative root 3 over 2, because that's your x-coordinate. We can find secant and take the reciprocal. Not supposed to have a radical in the denominator, so multiply by that root 3. Okay. Tangent is y over x. So the y is 1/2. X is negative root 3 over 2. So complicated fraction, but if you remember that fractions is really division, I'm dividing 1/2 by negative root 3 over 2. And dividing fractions is multiplying by the reciprocal. 2's cancel. Can't have a radical in denominator. So we end up with negative root 3 over 3. Okay, cotangent is going to be the reciprocal. So I'm going to do negative root 3 over 2 over 1/2. So we'll multiply by the reciprocal. 2's cancel, and you'll get negative root 3. All right, find all 6 trig functions when you know that your angle is pi over 3. So if we're looking on our unit circle, these were our pi over 3's. That ordered pair for pi over 3, which is right here, 1/2 root 3 over 2. All right, so sine would be the y-coordinate. So I want you to notice something. The sine of our pi over 3 is the cosine of our pi over 6. That's because 30 and 60 degrees together make 90 degrees. They're complementary. So I can use that reciprocal for cosecant as well. So the reciprocal of root 3 over 2 is 2 root 3 over 3. Cosine t would be the x-coordinate. Again, I want you to notice the cosine of pi over 3 is the same as sine of pi over 6. Reciprocal. Tangent, y over x. Multiply by the reciprocal. Okay, another pattern to see here. The tangent of pi over 3 is the cotangent of pi over 6, which means the cotangent of pi over 3 is the tangent of pi over 6. All right, this is a really good reference table for quadrant 1 angles. These are all quadrant 1 for unit circle. All right, it's got sine, cosine, tangent, cosecant, secant, cotangent for your 0, 30, 45, 60, and 90. So 0, pi over 6, pi over 4, pi over 3, pi over 2. So wherever you see these undefineds, that meant the denominator was a 0. All right, so specifically I want you to look at pi over 2. Actually, let's look at 0. So look at tangent and cotangent. Cotangent is undefined, tangent is 0. The reciprocal of 0 is undefined. All right. Because at 0 degrees, you have 1, 0. So this is 1 over 0, which is 0. Or cotangent would be 1 over 0, which is undefined. All right, so we're using a mnemonic device to help you remember what's positive and what's negative in each quadrant. Okay, so quadrant 1. Okay, we had a positive x, positive y. Quadrant 2, negative x, positive y. Quadrant 3, x, negative y. Quadrant 4, positive x, negative y. And because these signs change depending on the quadrant, that changes the signs of your trig functions as well. So we use a mnemonic device. All students take calculus. All goes in quadrant 1. That means all trig functions are positive. S goes in quadrant 2, and S stands for sine. So sine is positive in quadrant 2. Also, it's reciprocal, cosecant. T is quadrant 3. T for tangent. So tangent is positive in quadrant 3, and that makes sense because you have a negative y over negative x. Negative over negative is positive. And C goes in quadrant 4. That stands for cosine. Reciprocal secant. All right, so now I'm going back to that unit circle foldable that I did in class. And again, if you're not here, this is posted in your Blackboard. You can cut it out and do the things you want to. If you want to cut it out, it ends up looking like, where'd it go? Like ultimately, this is kind of what it's supposed to look like. Okay. So let's start with our quadrantals. All right, tangent. Let's do tangent 0. Tangent is y over x, 0 over 1, that would be 0. Tangent pi over 2, y over x, that will be undefined. Tangent, I'm going to make these pi. Tangent 180 degrees. Okay, 0 over negative 1, that would be 0. Tangent 3 pi over 2, and that's y over x, so that's undefined. And tangent 2 pi, y over x, 0. Okay, now we're on our 60 degrees. This is all pi over 3 here. Remember, tangent pi over 3 is y over x. I have that right here. Division fractions, multiplication of a reciprocal. We get root 3. So tangent pi over 3 is root 3. Tangent 2 pi over 3. Okay, the only thing that's positive in quadrant 2 is sine. So this is going to be negative root 3. Tangent 4 pi over 3. Okay, tangent is positive in quadrant 3. And then we have tangent 5 pi over 3. Tangent is negative in that quadrant. And these are our pi over 4 angles. So tangent pi over 4, y over x. Tangent pi over 4 is 1 because the x and y are the same. We'll now move on to quadrant 2. Tangent is negative in quadrant 2. Tangent 5 pi over 4. Tangent is positive in that quadrant. Tangent 7 pi over 4. Tangent is negative in quadrant 4. And our last ones are pi over 6s. Okay, that's y over x, so 1/2 over root 3 over 2. Multiply by the reciprocal. Can't have that radical in the denominator, so multiply by that root. Root 3 over 3. Quadrant 2. Tangent 5 pi over 6. Tangent is negative in quadrant 2. Why am I writing so big? Goodness. In quadrant 3, tangent tangent is positive. And in quadrant 4, tangent for 11 pi over 6 is negative. Okay, so use reference angle to find all 6 trig functions of negative 7 pi over 4, excuse me. So the first thing I want is the reference angle. Since it's a 7 pi over 4 is the reference angle. So I know that the ordered pair to start with is root 2 over 2, root 2 over 2. 7 pi over 4, negative 7 pi over 4, however. All right, so if you remember, when the angle is positive, okay, when the angle was positive, it was pi over 4. Quadrant 2 would be 1 less than, so 3 pi over 4. Quadrant 3 would be 1 more, so 5 pi over 4. Quadrant 4 would be double minus 1, 7 pi over 4. But we're going the other direction. So what our normal quadrant 4 angles would be in negatives would be in quadrant 1. So 7 pi over 4, negative 7 pi over 4 falls in quadrant 1. All right, so that means everything stays positive. So sine be the y coordinate. Let's do the reciprocal. Oh my gosh, my handwriting's terrible. Cosine, x coordinate. Secant, since sine and cosine are the same, then secant and cosecant are going to be the same. And tangent, y over x, tangent is 1 here. And the reciprocal of 1 is 1. Okay, so use reference angles to find all 6 trig functions of an angle with terminal side intersecting unit circle. It's a lot of information. Pair. So the first thing I noticed with that order pair is that the x, hello, 1/2, which means the reference angle is pi over 3. What quadrant does it put negative x and negative y? That's quadrant 3. All right, so sine would be the y coordinate. Cosecant would be the reciprocal. Get that radical out. Cosine would be the x, reciprocal. Tangent, okay, we did tangent, and pi over 3. Tangent pi over 3 is root 3. And in quadrant 3, it stays positive. Remember we talking about a couple sections ago, that the tangent of pi over 3 is the cotangent of pi over 6. So that must mean the tangent of pi over 6 is the cotangent of pi over 3. But we can get that by doing the ordered pairs. Cotangent is x over y. Okay, we've done this enough to know that this is root 3 over 3. Use reference angles to find all 6 trig functions of 3 pi over 2. So 3 pi over 2 is quadrantal. And the key feature of a reference angle is that the angles have to be acute. So this is not going to have reference angles. If it's quadrantal, our angles are either going to be 0, 90, or 180. It's not going to be anything else. It cannot be acute. Okay, but I do know where 3 pi over 2 is on the unit circle. It has an ordered pair of 0, -1, which is all I need to know. Sine is the y coordinate. Reciprocal of sine would be cosecant. Cosine is the x coordinate. Reciprocal of 0. Okay, this is going to be undefined. Tangent y over x, it's negative 1 over 0, that's undefined. Reciprocal of undefined, 0. Okay, using even and odd functions to evaluate. So an even function is a function that two inputs that are opposites have the same output. So that means if I plug in a positive and a negative of the same number, I'm going to get the same output. So let me give you an example. I'm going to use this function. Let's say I plug in a positive 3. All right, well, 3 squared is 9. If the function's even, that means if I plug in the opposite, so negative 3, I should get the same output. Negative 3 squared is positive 9. All right, so the last thing I want you to see with this is the symmetry. The symmetry for both of these is the y-axis. An odd function, two inputs that are opposites are going to have outputs that are also opposites. Okay, so if I plug in, let's say I'm going to do the cube root. If I plug in a positive 1, the cube root of 1 is 1. If I plug in opposite, the cube root of negative 1 is negative 1. What I plugged in was opposite, what I got out was opposite. So you can see on both of these are both considered odd functions. Their symmetry is diagonal. It's symmetric to the origin. All right, so our trig functions can be considered even and odd as well. So you have two even functions, that's cosine and secant. And you have 4 odd functions. There is a mistake on here. These down here should be negative. Your tangent and cotangent should be negative. Well, we can use our unit circle to show why this works. So I have t and negative t. So if I do cosine of t on the unit circle, that's going to give me x because it's a coordinate. If I do cosine of negative t on that unit circle, that gives me positive x. That's what makes it even. And if I do sine, okay, sine is going to be that y. But if I do sine of negative t, so that's opposite, that's negative y. That's what makes it odd. Okay, so if secant, so specific to secant, so the secant is even. So if I plug in its opposite, I get the same value. So t and negative t, I'm going to get the same value. So secant of negative 2 is also, secant of negative t is also positive 2. Cotangent, okay, cotangent is odd. So the opposites. Okay, so if my plugins are opposites, then my outputs will be opposite. So positive t, negative t, so my inputs are opposite. My outputs need to be opposite. So positive root 3, then I'm going to have negative root 3. So we spent a lot of time talking about sine and cosine as x and y. Okay, but if we kind of put those back, okay, we know tangent is y over x. Well, y is sine and x is cosine. So tangent, instead of just thinking it in terms of y and x, I can think of tangent in terms of sine and cosine. So tangent is sine over cosine. So that would make the reciprocal cotangent cosine over sine. Cosecant being the reciprocal of sine, 1 over sine. And secant being the reciprocal of cosine, be 1 over cosine. Tangent 45 degrees. Okay, we've done that enough to know that that is 1. Okay, is root 2 over 2 over root 2 over 2. Cosecant 7 pi over 6. All right, so that's got a reference angle of pi over 6. With it being 7 pi over 6, this is quadrant 3. Cosecant is the reciprocal of sine. So if I do sine pi over 6, that's 1/2. So we do its reciprocal. In quadrant 3, sine is negative. Okay, secant 5 pi over 6. We have reference angle, pi over 6. We have 5 over 6. That's 1 less. So it's quadrant 2. Secant is the reciprocal of cosine. That's root 3 over 2. So we'll do the reciprocal. But in quadrant 2, cosine is negative. Multiply by root 3. All right, simplify the following. What this means is get your expression to one trig function, not 2 or 3 or 4, and best, no fractions. It's not always, but it's best. So, secant. I got secant over tangent. So, good rule of thumb to follow is to change to sine and cosine. What the heck? All right, secant, 1 over cosine. So I change secant to 1 over cosine. Tangent, sine over cosine. So I change tangent to sine over cosine. Okay. In the moment, I've made it more complicated than it needs to be. We're going to simplify it. Division of fraction, multiplication by the reciprocal. Sine cancels, means it really is 1. So I have 1 times 1 in the numerator, 1 times sine in the denominator. Can we change that? I don't want a fraction. 1 over sine is cosecant. Now it's one trig function, and it happens to not be a fraction. Okay, I've got mixed trig functions here. I want it to be down to 1. So I'm going to change tangent to sine over cosine. So tangent, sine over cosine. Now, I don't have any symbols between that tangent and cosine, so that is an understood multiplication. And I don't need to change cosine, but I do need to put it over 1 so that I have 2 fractions. So I change cosine to cosine over 1. Well, cosine cancels cosine. What really means it reduces to 1. So I have sine x times 1 over 1 times 1. One of the other identities that you need to know, okay, that kind of stems from doing things like these 2 examples, is our cosine squared plus sine squared equals 1. We talked about this in, I think, 5.1 and 5.2. All right, but you can do some other things with this particular identity and create whole new identities. So if we divide everything through by cosine squared, I mean, divide literally everything. That way it keeps everything the same value. Cosine squared over cosine squared is 1. That's easy. Sine squared over cosine squared. Well, sine over cosine is tangent. So sine squared over cosine squared is tangent squared. 1 over cosine squared, well, that's the reciprocal of cosine, which is secant. Okay, and you can rearrange that a few different ways, but this is the primary one. We can also rearrange that cosine squared plus sine squared by dividing everything through by sine squared. Okay, cosine over sine is cotangent. Cosine squared over sine squared. Cotangent squared. Sine squared over sine squared is 1. 1 over sine squared, that's reciprocal. Reciprocal of sine is cosecant. And of course, all the rearranging of that. But this one is that primary one. All right, so on this one, I accidentally have too many equal signs. All right, I've got secant t equals negative 17 over 8. Secant is the reciprocal of cosine. So cosine is x over radius. So secant must be radius over x. Radius is always positive, so the radius is positive 17, which makes the x negative 8. And I am asking you to find the values of all 6 trig functions, which means we need a y. So we're going to use Pythagorean theorem, x squared plus y squared equals radius squared. So we know x is negative 8. Radius is 17. So 64, 289. If we subtract 64, that's 225. And then take the square root of both sides. Y is plus or minus 15. I have to figure out which one is the right answer. Is it the positive 15 or is it the negative 15? Well, that goes back into the second piece of information. It says t is between 0 and pi. 0 is here, pi is there, and it says t is somewhere between them. So I'm somewhere up here, which means the y is positive 15. All right, I've got everything I need now. Sine t would be y over radius, so 15 over 17. Cosecant would be the reciprocal. Secant would be x over radius, and we were given secant. Tangent would be y over x. Cotangent would be x over y. All right, now evaluating reciprocal functions in your calculator recognizes sine, cosine, and tangent. It does not do secant, cosecant, and cotangent. So if I want to enter these in the calculator, I have to use the reciprocals. Cosecant is 1 over sine, with that 5 pi over 7 being in radians. Okay, so when I type this in my calculator, make sure I'm in radians, and you can see I have it. 1 over sine, 5 pi over 7. And we get 1.279. And then B, this is cotangent. So I'm going to use the reciprocal. 1 over tangent. And your negative pi over 8, that's also in radians. It does not have a degree symbol. Negative 2.414. All right, so your trig values assessment is going to go over all of these unit circle values, especially this section. Okay, if you can get that first quadrant memorized, then you'll know the remaining 3.